Hi folks, welcome back to 8.10 partial fractions. So our first video was mostly an overview, and in this second video we're actually going to do some of these problems from the first step to the last step all by ourselves. So we're going to start with example number 1 here, where we see f of x equals 5x plus 16 over x squared plus 10x plus 24. So our first step here is going to be to factor the denominator. All right, so we're going to factor the denominator, and that's going to give us 5x plus 16 over x squared plus 10x plus 24, which is going to be 5x plus 16 over x plus 6 and x plus 4. Okay? Now, if you don't know, it doesn't really matter whether you have x plus 6 first or x plus 6 second. Okay? So if you wrote it like x plus 4 times x plus 6, that is totally fine. But once we factor the denominator, now we're going to move on to step 2, where we set up, we find a common denominator. We split into partial fractions and find a common denominator. Okay, so let's see what that gets us. 5x plus 16 over x plus 6 times x plus 4 is going to equal, well, both of these factors are linear on the bottom, so we're going to have a over x plus 6, so we need a constant, plus x plus 4 is a linear as well, so I need a constant on the top, b. All right, now we need to find a common denominator. So to make x plus 6 into what we have over here, I'm going to multiply this by x plus 4. And if I do that on the bottom, I also need to do that on the top. Now, what do I need to multiply the second fraction by to get the same denominator? I need to multiply it by x plus 6 on the bottom, and then x plus 6 on the top, okay? So we found our common denominator, and now we're ready to go ahead and get rid of that denominator. Once they're the same, we can get rid of them. And now we create an equation with just the numerator. So 5x plus 16 equals a times x plus 4 plus b times x plus 6. Now, we're going to go ahead and solve this equation, but I'm going to show you a shortcut that you can use for some of these to help you move along a little bit faster, okay? So instead of distributing, which is what I did in the first video, what I'm going to do is pick certain values of x to help me solve for a and b a little bit faster, okay? So in the first thing, I'm going to let x equal negative 4. And let's see what happens when we plug in negative 4. I get 5 times negative 4 plus 16 equals a times negative 4 plus 4 plus b times negative 4 plus 6. Okay, so what happened when I plugged in negative 4? I mean, some things didn't look like they changed a whole lot, but some things, they went to 0. And that's really nice because now the a is going to go away in the equation. And so that's going to leave me with, on the right-hand side, b times negative 4 plus 6 is 2. On the left-hand side, we have negative 20 plus 6 is negative 4. So we get a b value of negative 2. Okay? So instead of a system of equations, if you can pick a letter or a number for x, sometimes some of the terms go away, like it did in this case. So let's think about what else we could pick. What if we let x equal negative 6? Let's see what happens then. 5 times negative 6 plus 16 equals a times negative 6 plus 4 plus b times negative 6 plus 6. Well, this is really nice because now this one goes away, and that allows me to find a. So negative 30 plus 16 is negative 14 equals negative 2 times a is, or negative 2, times a, and this is going to give me a equal to 7. Okay? So I found my a and my b, and now my last step is just to plug them back in to my partial fraction. So our final answer, this is going to be equal to a over x plus 6, so 7 over x plus 6, plus b over x plus 4, or negative 2 over x plus 4. Now, some people like to take that minus sign and write it like in between and then just have the 2 on the top, and that's fine too. I would say either version is fine, but this is our partial fraction decomposition, okay? So we've taken one expression and turned it into 2 partial fractions. All right, let's take a look at one more example. So, example number 2. F of x equals negative 5x minus 19 over x squared plus 8x plus 16. So, let's go ahead and break this up into its denominator, into its factors. So, we get negative 5x minus 19 over, when I factor x squared plus 8x plus 16, I get x plus 4 times x plus 4. Now what that means is I really have a repeated linear factor. So x plus 4 is the linear factor, but it's repeated because it happens twice. Now that means when we break it down into its partial fractions, we need a constant over the linear, plus we need to count for the fact that it's repeated, so b over x plus 4 squared. Okay. Now let's go ahead and make a common denominator. So for the first fraction, I need to multiply both top and bottom by x plus 4 to make that term have the same denominator as the other side. Plus b over this one already has the same denominator, so I don't need to multiply it by anything other than 1. Now that all my denominators are the same, I'm going to cross those out and write an equation only dealing with the numerator. Negative 5x plus 19 equals a times x plus 4 plus b. Okay. So let's be clever about the numbers we try for x. Now I notice there's an x plus 4, so the first number I'm going to try is x minus 4. So x equals negative 4. That will give me negative 5 times negative 4 plus 19 equals a times 0 plus b. Okay, this is good. This gets me b. So I get 20. That's a minus. 5x minus 19. X minus 19, and whoop. Same thing here, this plus sign needs to be a minus. Alright, so now I have 20 minus 19, which is 1, and that gives me my b. Now, once I have my b, I can go ahead and see what I need to do to find my a. So in this case, I'm going to write an equation that only has the x's. So negative 5x equals ax. Negative 5x equals ax. That means that a equals negative 5. Okay, so I'm combining the strategy I used in the first video with the strategy I used in that first problem I did in this video. And now my final answer is to write out what my a and b are in the partial fraction. So I get negative 5 over x plus 4 plus 1 over x plus 4 squared. And this is my partial fraction decomposition for question number 2. All right, we're going to go ahead and stop here for this video. Come on back for a few more examples, and I'll see you there.